mag-aral na tayo. Halina, 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 mag-aral na tayo.
Maraming salamat, Ma'am Weng. #maganda ka pa ba? Joke lang. Kayo naman, mga batang mandunong, samahan niyo ang tita ko ipakilala sa inyo ang susunod na review teacher para sa grade 10 mathematics gamit ulit ang learning grade module natin. Siya ay teacher 1 ng mataas na paaralang CLAID Gonzales, dalagang-dalaga. Walang iba kung hindi si Teacher HAYDEE Agapito. Ma'am, ikaw na po.
Mathematics 10, Quarter 3, Week 1. Topic: Permutation. Goals. Number 1. Illustrate the permutation of objects. Number 2. Evaluate factorial notation. Number 3. Find the number of permutations of n objects taken R at a time. I will be your guide as we journey through this lesson. I'm Miss Heidi D. Agapito from Mataas na Paralang Neptali A. Gonzales. Let's begin by getting to know the fundamental principle of counting. It is a rule used to count the total number of possible outcomes in a situation. It states that if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible ways. Let's look at an example. Nathaniel wants to take a summer class at the community center. The table shows the class options he is considering. All the classes offered only Monday and Wednesday. Draw a tree diagram to find the number of different classes and day outcomes. Before we proceed, let's just look first at this table. Sa column na to, ang classes na kinoconsider ni Nathaniel ay swimming, martial arts, and basketball. Sa column na to, yung days offered ng mga classes, Monday and Wednesday. Let's draw a tree diagram. May columns para sa class, day, at outcomes. Tandaan, 3 ang pinagpipiliang klase ni Nathaniel. Isa na nga dito ang swimming. At ang swimming ay ino-offer lamang ng 2 araw. So, 2 ang pinagpipilian ni Nathaniel na araw. Isa na nga dito ang Monday. So, posible na piliin ni Nathaniel na mag-swimming tuwing Monday o mag-swimming tuwing Wednesday. Ang possible outcomes, swimming Monday o swimming Wednesday. Pwede rin niyang piliin na mag-martial arts tuwing Monday o mag-martial arts tuwing Wednesday. Ang possible outcomes niyan, martial arts Monday o kaya martial arts Wednesday. Pwede rin niyang piliin na mag-basketball tuwing Monday o mag-basketball tuwing Wednesday. Ang possible outcomes, basketball Monday o kaya basketball Wednesday. Ilan ba ang posibleng outcomes sa mga pinagpipiliang klase at araw ni Nathaniel? Bilangin natin. 1, 2, 3, 4, 5, 6. 6 total possible outcomes. Parehong tree diagram ito. Question: based on this diagram, how many classes did Nathaniel consider? Answer: 3. Bakit nga 3? Kasi 3 yung klase. May swimming, may martial arts, at may basketball. Ito ay kaparehong tree diagram gaya nung nauna. Question: how many days do the given classes offered? Answer: 2. Bakit nga 2? Kasi bawat klase, ino-offer siya ng 2 araw lang, Monday at Wednesday. Kaparehong tree diagram ito. Find the product of the number of classes and the number of days found in the previous 2 questions. Answer: 3 times 2 equals 6. Kung mapapansin ninyo, pwede naman tayong gumamit ng multiplication sa paghanap ng possible outcomes. Kailangan lang alam natin kung ilan ang choices o options natin. Gaya dito, alam natin kung ilan ang options or choices para sa class at kung ilan ang options or choices para sa day. Ikukumpara natin itong multiplication sa ginawa natin sa tree diagram na ito. Dahil kapag dumami pa ang choices or options, mas madami ang ililista na possible outcomes sa tree diagram. So kung makikita natin, mas convenient o mas shorter process kapag gumamit ng multiplication. Let's review. Number 1. How many classes did Nathaniel consider? Answer: 3. Number 2. How many days do the given classes offer? Answer: 2. Number 3. Find the product of the 2 numbers you found in number 1 and number 2. Answer: 3 times 2 equals 6. Saan pa ba natin pwedeng i-apply ang pinag-aaralan nating fundamental principle of counting? Tingnan natin sa example 1. 10 runners join a race. In how many possible ways can they be arranged as first, second, and third place? Ito ang ating 10 runners. Lahat sila nagko-compete para manalo. Ang mga pwedeng mapanalunan ay first place, second place, at third place. Question: ilan sa mga runners ang posibleng manalo ng first place? Answer: 10. Lahat sila at kahit sino sa 10 runners ay maaaring maging first placer. At meron na ngang nakakuha ng first place. Kaya ilan na lang sa mga runners ang posibleng maging second placer? Answer: 9. 9 na lang. Dahil dun sa original na 10 runners, may isa nang nanalo ng first place. Nabawasan na yung pwede pang manalo ng ibang places. 9 na lang ang pwedeng maging second placer. At may nakakuha na nga ng second place. Ilan na lang sa mga runners ang pwedeng manalo ng third place? Answer: 8. Dahil sa original na 10 runners, may nanalo ng isang first place at may nanalo ng isang second place. Kaya yung naiwang 8 runners, sila na lang yung posibleng manalo ng third place. At may nakakuha na nga ng third placer. By fundamental principle of counting, what we do is multiply the 3 numbers. 10 times 9 times 8 equals 720 ways. Speaking of runners, kilala nyo ba siya? At alam nyo ba ito? To date, our very own Elma Muros holds the most number of individual medals among Filipino athletes. She holds a total of 15 gold medals as she was recognized as the best of the top 10 Southeast Asian Games Amazing Athletes in Philippines Track and Field. This is a sport which includes the skill of running, among others. Muros medals were won over a period of 18 years from 1983 to 2001. Next example na tayo. If Kate has 12 t-shirts, 6 pairs of pants, and 3 pairs of shoes, how many possibilities can she dress herself up for a day? Meron siyang 12 colored t-shirts, 6 pairs of pants, 3 pairs of shoes. Question: ilan sa mga t-shirts ni Kate ang pwede niyang pagpilian para maisuot? Answer: 12. Kahit alin dyan, kahit anong color dyan, pwede niyang isuot. Next question: ilan sa mga pants ni Kate ang pwede niyang pagpilian para maisuot? Answer: 6. Kahit alin dyan sa mga pants na yan ay posible niyang maisuot. Last question: ilan sa mga shoes ni Kate ang pwede niyang pagpilian para maisuot? Answer: 3. Kahit alin dyan, pwede niyang maisuot. Now, by fundamental principle of counting, what we do is multiply all three numbers. 12 times 6 times 3 equals 216 possibilities to dress up. Example 3. In how many ways can Rowella arrange 4 potted plants in a row? Tingnan natin ang 4 potted plants. Meron din tayong first spot, second spot, third spot, and fourth spot. Ibig sabihin, ito yung mga pwesto o pagpupwestuhan ng mga potted plants. Question: ilan sa mga potted plants ni Rowella ang pwede niyang ilagay sa first spot? Answer: 4. Kahit alin dun sa 4 na potted plants, pwede niyang piliin para ilagay sa first spot, pero isa lang yung pipiliin niya. Ito yung napili na ilagay ni Rowella sa first spot. Dahil naipwesto na niya yan dyan, ilan na lang ang pwede niyang pagpilian para ilagay sa second spot? Answer: 3. 3 na lang. Kasi may isa na ngang nakapwesto, yung naiwang 3 pwede niyang pagpilian para ilagay dun sa second spot. At ito nga yung napili niya. Dahil may napili na siyang 2 potted plants, ilan na lang ang pwede niyang pagpilian para ilagay dun sa third spot? Answer: 2. 2 na lang. At ito nga ang napili niya. Dahil naipwesto na niya sa first, second, and third spot yung 3 potted plants, ilan na lang yung naiwan para sa fourth spot? Isa na lang. At ito na nga yung nilagay niya doon sa fourth spot, doon sa huling spot. By fundamental principle of counting, we multiply 4 times 3 times 2 times 1 equals 24 ways to arrange the 4 potted plants in a row. Example 4a. How many 3-digit numbers can Pia form using the numbers 1, 3, 5, 7, 9 if repetition is allowed? Kapag sinabing repetition is allowed, a particular number can be used more than once. Ibig sabihin, pwedeng umulit yung isang number. For instance, 111, 355, 779. So, lalagyan natin ng first digit, second digit, third digit. Ang choices natin, 1, 3, 5, 7, 9. 5 numbers ito. Ilan sa kanila ang pwedeng isulat o ilagay ni Pia sa first digit? Answer, 5. Kahit alin sa 5, pwede niyang ilagay as first digit. Sabihin na natin may nalagay na siyang number. Susundan niya tong 111. For example only. So may nilagay na siya na 1. Next question. Ilan na lang ang pwede niyang pagpilian para isulat o ilagay sa second digit? Answer, 5. 5 pa rin. Kasi sabi sa kondisyon, repetition is allowed. Pwedeng umulit yung isang number. So, susundan natin, ang first digit ni Pia ay 1, ang second digit niya ay 1. Last question. Ilan ang pwede pa niyang pagpilian para isulat o ilagay as third digit? Answer, 5 pa rin. Kasi nga, sinasabi, repetition is allowed. Pwedeng umulit ang isang number. At nabuo na nga ni Pia yung kanyang 3 digits. 111. By fundamental principle of counting, we multiply all 3 numbers. 5 times 5 times 5 equals 125, which is the 3-digit numbers that can be formed. Example 4b. How many 3-digit numbers can Pia form using the numbers 1, 3, 5, 7, 9 if repetition is not allowed? Pansinin ninyo, ito ay kabaliktaran ng naunang example. Kapag sinabing repetition is not allowed, a particular number can only be used once. Ibig sabihin, isang beses mo lang pwede gamitin yung number at hindi na pwedeng ulitin. For instance, 135, 791, 539. Na kung mapapansin ninyo, sa bawat 3-digit numbers na yan, ay walang umuulit na number. Hanap na tayo ng first digit, second digit, third digit. Ang choices natin ay 1, 3, 5, 7, 9. 5 yan. Ilan sa 5 numbers na yan ang pwedeng isulat o ilagay ni Pia as first digit? The answer, 5. Kahit alin dyan sa 5 yan, ay pwede niyang isulat as first digit. Let us assume na napili niya ay 1. Ilan na lang ang pwede niyang pagpilian para sa second digit? Answer, 4. 4 na lang. Kasi, ang kondisyon, repetition is not allowed. Hindi na pwedeng umulit yung number na ginamit mo sa first digit. So, ginamit niya ay 1, hindi na pwedeng ulitin si 1. Para sa second digit, 4 na lang ang natira at napili nga niya ngayon ay 3. Meron na siyang first and second digit. Ilan na lang ang pwede niyang pagpilian para sa third digit? Answer, 3. 3 na lang. At ang kanyang third digit ay 5. Buo na yung 3-digit niya. 1, 3, 5. By fundamental principle of counting, we multiply all 3 numbers. 5 times 4 times 3 equals 60 na 3-digit numbers that can be formed. Let's do a little bit of review. We learned some counting methods, such as using tree diagrams and tables. When there is a big number of events, it is not reasonable to use the tree diagram or tables. Instead, use the fundamental counting principle to determine the number of ways of doing all the tasks together. The fundamental counting principle is the guiding rule for finding the number of ways to do two or more of these tasks. How? Multiply the number of elements in each group. Take note that in our previous examples, we considered the arrangement or order of objects, persons, or numbers as we applied the fundamental principle of counting. Keep in mind that arrangement or order is very important. Order is relevant in our lesson called permutation. What is permutation? Permutation is an arrangement or listing of objects in which order is important. Example: Mark Angelo is planning his activity on Saturday. He wants to mow the grass, go swimming, and do his homework. How many ways are there to arrange what he wants to do on Saturday? Let's take a look at this one. Mowing, swimming, homework has a different order compared to homework, mowing, and swimming. Even if they have the same activities, notice that in the first one, he wants to do mowing first, second is swimming, and the last would be homework. Compared to this group of activities, he wants to do his homework first, then mag-mowing siya ng second activity, and last activity niya ay swimming. How many ways are there to arrange these activities? We have the first activity, second activity, third activity. So, ang choices natin, mow the grass, go swimming, and do his homework. Tatlong activities yan. Ilan ang pwede niyang pagpilian para maging first activity niya? Answer? 3. Kahit alin dun sa tatlo, pwede niyang maging unang activity. Nakapili na siya. Let's just say that he chose mowing first. Ilan na lang ang pwede niyang pagpilian para maging second activity niya? Answer? 2. Dalawa na lang, kasi napili na niya yung isa para sa first activity. Let's say that he chose swimming as his second activity. Ilan na lang ang choices niya para sa third activity? 1. Isa na lang. At yun ay homework. So our solution would be to multiply all three numbers. 3 times 2 times 1 equals 6, which is the number of ways to arrange the three activities. The number of n permutations taken n at a time is denoted by NPN. The total number of permutations of a set of n objects is given by NPN equals n times the quantity n minus 1 times the quantity n minus 2 up to 3 times 2 times 1. Let's apply this by using an example. 8P8. We will show the total number of permutations of a set of n objects as given by, and this is part of our example. NPN means n permutations taken n at a time. So 8P8 is 8 permutations taken 8 at a time. N is equal to 8. The quantity n minus 1 is 8 minus 1 equals 7. The quantity n minus 2 is 8 minus 2 equals 6. And so forth and so on down to 3, 2, 1. So our solution, 8 permutations taken 8 at a time is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 40,320 permutations. What we basically did was multiply 8 by the numbers that followed it in descending order. So, pababa. Let's use an example. In how many ways can Katrina arrange 6 books on a shelf? Imagine that these are the 6 books that need to be arranged on this shelf. We have the first spot, second spot, third spot, fourth spot, fifth spot, and sixth spot. Yung first to sixth spots na yan, dyan ipupwesto yung mga libro ni Katrina. Let's focus on the first spot. Ilan ang pwedeng pagpilian ni Katrina para makapaglagay siya ng libro sa first spot? Answer, 6. Kahit alin doon sa 6 na libro ni Katrina ay pwede niyang ilagay sa first spot. At napili niya ang green book. Pinwesto na niya sa first spot. Ilan na lang ang pwede niyang pagpilian para makapaglagay siya sa second spot? Answer, 5. 5 na lang kasi from the original 6 books, kumuha na siya ng isa at nilagay na niya sa first spot. So kahit alin dun sa 5 librong naiwan ay pwede niyang ilagay sa second spot. At napili nga niya yung orange book. Then, ilan na lang ang pwede niyang pagpilian para makapaglagay siya ng libro sa third spot? Answer, 4. 4 na lang. Kasi from the original na 6 books, kumuha na siya ng 2. Ipinwesto na niya yung isa sa first spot at yung isa sa second spot. Kahit alin dun sa 4 na yon ay pwede niyang ipwesto sa third spot. At napili niya ang yellow book. We continue. Ilan na lang yung pagpipilian niya para sa fourth spot? 3. 3 na lang ang pagpipilian niya. Dahil from the original 6 books, nakuha na niya yung 3 na pwesto na niya sa first, second, and third spot. At kahit alin dun sa 3 librong yon, pwede niyang piliin yung ilalagay niya sa fourth spot. Napili niya yung red book. Ilan pa ang pwede niyang pagpilian para makapaglagay siya sa fifth spot? Answer, 2. 2 na lang yung pwede niyang pagpilian. At ang napili niya ay blue book. And then we go to the sixth spot. Ilan na lang yung naiwang libro para sa sixth spot? 1. Isa na lang. At yun ang nilagay niya sa sixth spot. Now, using the permutation, this is our solution. The permutation of 6 objects taken 6 at a time, or 6p6, is equal to 6 times 5 times 4 times 3 times 2 times 1 equals 720 ways. What we basically did was multiply 6 by the numbers that followed it in descending order. In how many ways can 7 students be arranged in a line? These are the 7 students. First, second, third, fourth, fifth, sixth, seventh. Kung sila ay magre-rearrange or mag-iiba-iba ng pwesto sa linya, ilan sa kanila ang pwedeng pagpilian para ma-assign or makapwesto sa first spot? Answer: 7. Kahit sino sa 7 students na ito ay pwedeng pumwesto sa first spot. Ang unang assigned ay yung student na naka-yellow shirt. Siya ang assigned sa first spot. Ilan na lang ang pwedeng pagpilian para sa second spot? Answer: 6. Kahit sino dito sa 6 students na ito ay pwedeng piliin para pumwesto sa second spot. Yung student na male na naka-blue sweatshirt ang pupwesto sa second spot. Ilan na lang ang pwedeng pagpilian para pumwesto sa third spot? Answer: 5. Kahit sino dito sa 5 students na ito ay pwedeng pumwesto sa third spot. Yung student na female, naka-blue sweatshirt, ang pupwesto sa third spot. Ilan na lang ang pagpipilian para may pumwesto sa fourth spot? Answer: 4. Kahit sino sa 4 students na ito ay pwedeng pumwesto sa fourth spot. Yung male student na naka-white polo or white uniform ang assigned or pupwesto sa fourth spot. Ilan na lang ang pagpipilian para sa fifth spot? Answer: 3. 3 students na lang. Kahit sino dito sa 3 students na ito ay maaring pumwesto sa fifth spot. Yung female student na naka-white uniform ang napili para sa fifth spot. Ilan na lang ang pagpipilian na students para sa sixth spot? Answer: 2. 2 na lang sila. Kasi yung unang 5 students nakapwesto na sila from first, second, third, fourth, and fifth spots. Kahit sino dito sa 2 students na to ay pwedeng pumwesto sa sixth spot. Yung male student na naka-shorts ang nakapwesto or na-assign sa 6th spot. Now, ilan na lang ang para sa 7th spot? Isa na lang siya. Itong student na lang na to. So, siya na ang pupwesto sa 7th or last spot. Now, using permutation, this is the solution. 7p7 or the permutation of 7 students taken 7 at a time is 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 5,040 ways wherein the students can be arranged in a line. Basically, what we did was multiply 7 by the numbers that followed it in descending order. If you noticed, in our previous examples, we multiplied a number by the numbers that follow it in descending order. This is a very significant part of permutation, and this is called factorial. What is factorial? Factorial is the product of all positive integers less than or equal to a given positive integer and denoted by that integer n and an exclamation point. Thus, n exclamation point is actually read as n factorial. N factorial equals n times the quantity n minus 1 times the quantity n minus 2 up to 3 times 2 times 1. Examples. 5 factorial equals 5 times 4 times 3 times 2 times 1 equals 120. 4 factorial equals 4 times 3 times 2 times 1 equals 24. 3 factorial equals 3 times 2 times 1 equals 6. 2 factorial equals 2 times 1 equals 2. 1 factorial equals 1. And 0 factorial equals 1. Most scientific calculators have a key that calculates factorial. The key will look like x factorial or n factorial depending upon the kind of calculator. This is an example of a calculator which has the x factorial function. The red arrow points to x factorial. For example, to find 4 factorial, press 4, press shift as shown by the blue arrow, then press x factorial. You will get 24. To gain a better understanding on factorials, let's relate the concept of factorials to the concept of exponent. In factorial, the process is descending. For example, we have a set of descending positive integers from 5 all the way down to 1. While in exponent, the process is increasing. In factorial, we multiply a number by the numbers that follow it in descending order. Example, 5 times 4 times 3 times 2 times 1 equals 120. Whereas in exponent, we multiply a number by itself to get to a higher value. Example, 2 times 2 times 2 times 2 equals 16. Lastly, in factorial, instead of writing 5 times 4 times 3 times 2 times 1, we can write it as 5 factorial. In exponent, instead of writing it as 2 times 2 times 2 times 2, we can write it as 2 to the 4th power. After learning that about factorials, let's go ahead and gain some practice working with factorials. Examples. 10 factorial equals 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 3,628,800. Next example. 10 factorial over 8 factorial times 3 factorial. The 10 factorial in the numerator would be equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, 8 factorial times 3 factorial would be the quantity 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times the quantity 3 times 2 times 1. Before we go to the next line of the solution, just want to take note of this part. This is the same effect as what we did a while ago. But this is the shortcut process. 10 factorial can also be written as 10 times 9 times 8 factorial. And in the denominator, 8 factorial times 3 factorial would be written as 8 factorial times the quantity 3 times 2 times 1. And we cancel out 8 factorial in the numerator and 8 factorial in the denominator because 8 factorial divided by 8 factorial would just be reduced to 1. That will leave us with 10 times 9 in the numerator and 3 times 2 times 1 in the denominator. What about this? This is a shortcut which makes life or math life easier. But for beginners, you may just want to opt to use this one so that we would know how to correctly solve factorials. Let's go to the next line. The numerator would be equal to 3,628,800 and the denominator would be the quantity of 40,320 times 6. Next, it would be equal to 3,628,800 over 241,920. Dividing the numbers would give us 15. Last example. 5 factorial times 3 factorial equals the quantity 5 times 4 times 3 times 2 times 1 times the quantity 3 times 2 times 1 would give us 120 times 6 equals 720. After gaining some practice by working on factorial problems, let's move on to permutation of n objects taken r at a time. The number of permutations of a set of n objects taken r at a time is given by npr equals n factorial over n minus r factorial, where n refers to the total items in the set and r refers to the items taken from the set. The generalized expression of the formula is, how many ways can you arrange r from a set of n if the order matters? Let's use an example. An ice cream shop has 20 flavors. Patrick wants to buy a 4-scoop cone with 4 different flavors. How many cones could he buy if the order of the flavors is important? Gustong bumili ni Patrick ng ice cream na merong 4 scoops na magkakaibang flavors. So may first scoop, second scoop, third scoop, fourth scoop. Ang available ay 20 different flavors. Ilan ang pwedeng pagpilian ni Patrick para sa kanyang first scoop? Answer, 20. Kahit aling flavor dun sa 20 available flavors ay pwede niyang piliin para sa first scoop. Pipili na siya at napili niya ang chocolate flavor. Ilan na lang ang pwede niyang pagpilian para sa kanyang second scoop? Answer, 19. 19 na lang kasi out of the original 20 available flavors, napili na niya yung isang flavor para sa kanyang first scoop. At tandaan natin, ang gusto niya, 4 different flavors. So, nakapili na siya ng next scoop na vanilla flavor. Ilan na lang ang pagpipilian niya para sa kanyang third scoop? Answer, 18. 18 na lang. Kasi from the original 20 available flavors, napili na niya yung dalawa para sa kanyang first scoop and second scoop. So para sa kanyang third scoop, napili niya yung blueberry flavor. Ilan na lang ang pwede niyang pagpilian para sa kanyang fourth scoop? Answer, 17. 17 na lang. Kasi from the original 20 available flavors, napili na niya yung 3 flavors para sa first, second, and third scoop. At ang napili niya para sa fourth scoop ay pistachio flavor. Nabuo na ang 4-scoop cone na gustong mabili ni Patrick. Using the fundamental principle of counting, pwede nating mahanap kung ilang cones ang pwede niyang mabili. Solution, 20 times 19 times 18 times 17 equals 116,280 different cones ang pwedeng mabili ni Patrick. This is the same word problem. An ice cream shop has 20 flavors. Patrick wants to buy a 4-scoop cone with 4 different flavors. How many cones could he buy if the order of the flavors is important? But this time, we're going to use permutation, where the formula is NPR equals n factorial over n minus r factorial, where n equals 20, which refers to the 20 available flavors, and R equals 4, which refers to the 4 scoops in the cone. Solution. 20p4, or the permutation of 20 flavors, taken 4 at a time. This is equal to 20 factorial over 20 minus 4 factorial. This is equal to 20 factorial over 16 factorial. And expanding it, 20 factorial is equal to 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 16 factorial would be equal to 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we could use the shortcut version, which is 20 factorial would be 20 times 19 times 18 times 17 times 16 factorial. And the denominator is just written as 16 factorial. And then you cancel out 16 factorial divided by 16 factorial because it will just be reduced to 1. Okay, so if we use this, it will give us 116,280 cones that Patrick could buy if the order of the flavors is important. Let's look at another problem. Solve 8p4, which is also permutation of 8 objects taken 4 at a time, where n equals 8 and r equals 4. That's 8p4, 8 factorial over 8 minus 4 factorial equals, just copy the 8 factorial, 8 minus 4 factorial will give us 4 factorial. Now expanding it, this 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial would be 4 times 3 times 2 times 1. We also have the shortcut version, where 8 factorial is 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. And then we cancel out 4 factorial in the numerator and the denominator, because 4 factorial divided by 4 factorial would just be reduced to 1. It will have the same effect, but we go back here, and the next line of the solution is, this is equal to 40,320, and the denominator is equal to 24. Dividing the numbers would be equal to 1,680 permutations. Try another problem. The Philippines is known as the land of beauty queens. Suppose there are 10 contestants in a beauty pageant. How many ways can the top 3 winners be selected? Part of the solution would be n equals 10, which refers to the 10 contestants, r equals 3, which refers to the top 3 winners. Following the formula, 10p3, which is the permutation of 10 contestants taken 3 at a time, is equal to 10 factorial over 10 minus 3 factorial. This will give us 10 factorial over 7 factorial. 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. This would give us, the numerator would be 3,628,800 and the denominator is equal to 5,040. Dividing the numbers would give us 720 ways that the top 3 winners will be selected. Or, just take note of this part na shortcut process, kung saan yung 10 factorial could also be written as 10 times 9 times 8 times 7 factorial. Yung 7 factorial would be written as is 7 factorial. Then we cancel out 7 factorial in the numerator and the denominator because 7 factorial divided by 7 factorial would just be reduced to 1. This shortcut process and this one would give us the same effect or the same answer. So let's continue. Speaking of beauty pageants, did you know that for years, the Philippines has proven to the world, or the universe rather, why it is known as a beauty pageant powerhouse? In terms of being the country with the most crowned beauty queens, the Philippines finished second on the list, a German market and consumer data company reported. The Philippines has reigned with a total of 15 crowns and titles from the Big Four international pageants: Miss Universe, Miss World, Miss International, and Miss Earth. Let's make a checklist of what we have done so far. This is based on the objectives that we have set at the beginning of the discussion. We have illustrated permutation of objects. We have evaluated factorial notation. We have solved for the number of permutation of n objects. We have also used the notation NPN equals n times the quantity n minus 1 times the quantity n minus 2 up to 3 times 2 times 1. And we have also used the formula NPR, which is the permutation of n objects taken r at a time, equals n factorial over n minus r factorial. Before we finally end the whole discussion, please allow me to share with you this quote from Gregory Willis. Life is full of permutations and combinations. Sometimes the order you do things matter, sometimes it doesn't. But in order to find the solution in life, you must work through each possibility presented to find your opportunity. Once again, this is Miss Heidi D. Agapito from Mataas na Paralang Neptali A. Gonzalez saying, thank you and wishing you a pleasant life.